Okay, so hello everyone, this is Akshay here. Today's question name is indexes of Subarray Sum. So whenever you heard the term subarray or pairs, then definitely the brute force technique directly should come into your mind is that form all the possible subarrays and whatever the question is saying, just you do that. So here the task is to find a contiguous subarray whose sum is equal to the target, right? We need to return one base indexes. So let's say the first subarray is forming from 0 to 2, from 0th index to second index, then you need to return 1 to 3, right? 1 comma 3. You need to find the first subarray. Okay, we do not need to find all the possible subarrays also, we just need to find the first subarray. So as the first step, let us verify the input and output, and then we can go ahead with the brute force technique and the optimized one. So we can clearly see for the first test case, that is 1, 2, 3, 7, and 5, this would be our first subarray, that is 2 plus 3 plus 7, which will give you 12. Similarly, here you can see target is 15. So sum of first 5 natural numbers, that is n into n minus 1 by 2, will give you 15. So this would be your first subarray. And index is starting from 0, 1, 2, 3, 4, 0 to 4, but we need to run one based indexing, so that is why 1 comma 5. Similarly, for 5, 3, and 4, the target is 2. There are no possible subarrays which will have the target as target sum as 2, right? So that means in that case, you need to return a minus 1. So what would be the brute force technique that you form all the possible subarrays? So what do we say when we what do we mean when we say subarray, right? That is we start from this one and then 1 comma 2 and then 1 comma 3 and then 1 comma 2 comma 3 comma 4. Similarly, we at the next iteration we'll start from 2, then 2 comma 3 and then 2 comma 3 comma 4, right? So that means we'll have a for loop that is from going from uh, testing we start from 1 and then we go for 2, right? So I equals to 0 till I less than n, and then when we are at position 1, we need to plus I plus 1 plus 2, and then similarly 2 plus 3, right? So we are taking the help of second nested for loop, that is j equals to I, j less than n, j plus plus. We'll do sum plus equals to array of j, and whatever the question is saying, we'll do that part. Please pause this video here now and try to code this approach by yourself, because that's a very self-explanatory approach. So we'll resume again. Since it was a brute force approach and we have seen multiple times, so why to waste the time on making the video again, right? So we have a for loop going from I equals 0 to less than n, and we have a nested for loop going from I equals j equals to 1 to j less than n. We are doing the sum of all the possible elements in the subarrays, and if sum is equals to s, we are returning the 1 plus indexing, that is 1 I plus 1 and j plus 1. And as soon as we got the sum is equals to target, we'll just return the array list, right? So after the end of the for loop, if still uh, that means if we are if our code has reached line of 57, then definitely the code has not found any particular subarray who has the sum of the elements equals to target. In that case, we'll just al dot add minus 1 and return the al. That would be it for the brute force technique. Let us submit this solution and then we'll go ahead with the optimized one. तो आप यहाँ पे देख सकते हो brute force भी submit हो गया, जो कि नहीं होना चाहिए था. एक बार देखते हैं इसका n की वैल्यू अगेन 10 power 6 है, तो इनका टेस्ट केसेस एरर है यार. If n is pointing to 10 power 6 and we have coded in the solution n square, that means 10 power 6 का square would be 10 power 12, which is greater than 10 power 8. So ideally this submission should not have happened. तो जो टेस्ट केसेस एक्चुअली में जो 10 power 6 को पॉइंट कर रहे हैं, वो टेस्ट केसेस इन्होंने मिस किया है, राइट? That's not pre-built in the what is the system. बट ठीक है. uh, हमने एक अलग सी वीडियो बनाया फॉर द ट्रिक दैट रियली इट मस्ट बी पॉपिंग अप नाउ, एंड यू कैन सी दैट वीडियो टू अंडरस्टैंड दैट व्हाट इज दैट 10 पर 8 लॉजिक, राइट? हमने लीड कोड और जीएफजी प्लेटफॉर्म दोनों को कंबाइन करके एक वीडियो शूट किया था. ओके, गोइंग बैक टू आवर ऑप्टिमाइज टेक्निक. ऑप्टिमाइज टेक्निक क्या हो गया यार? देखो, ऑप्टिमाइज टेक्निक में हाउ डू वी ऑप्टिमाइज इट? सो व्हाट एवर द थिंग्स व्हिच वी आर डूइंग इन ब्रूट फोर्स, दैट considering all the sub arrays, वो तो हमें करना ही होता है, but in an optimized way, that what are the redundant steps we can reduce? You can clearly say this is a redundant step, right? So how we can do this is that we will use a sliding window technique here, correct? And is it available in the topic stacks as well? I don't know. Prefix some sliding window, yeah, that's mentioned here, right? And this is in Amazon, Facebook, Google Visa. That's great. ठीक है. तो हम यहाँ पे क्या करेंगे, कि लेट्स टेक अ जेनरिक एग्जांपल. ये एग्जांपल मैंने पहले से लिख रखा है फॉर एक्सप्लेनेटरी पर्पसेस. सो वी विल टेक this particular element. Let me write it. We'll take 12, 18, 5, 11, 30, and 5, where the target is 69, right? Let me name the indexes as well. So this will be 0 index, 1, 2, 3, and 4. ठीक है. सबसे पहले हम क्या करेंगे यार? We will have a for loop, right? Starting from I equals to 0 till I less than n and I plus plus, right? And we will take the summation of those particular elements as we go forward. तो sum लिखते हैं हम यहाँ पे 12 हो गया. 12 plus 18 will give you what? 30. 30 plus 5 will give you 35. 35 plus 11 will give you 46. 46 plus 30 will give you 76, ठीक है. Now the problem here is that we have exceeded our sum. देखो हमें क्या चाहिए था, हमें कोई ऐसा फर्स्ट सब एरे चाहिए था जिसका जो सम है, जिसका जो सम ऑफ एलिमेंट्स हो that points to our target, but ऐसा हो नहीं रहा है यहाँ पे. तो as soon as we are exceeding our sum, as soon as we have got a window, first of all, if you see, we have got a window, right? And as soon as we are exceeding the sum, we need to decrease our sum, right? How we can do that? We can initialize the pointers here as, let's say this would be our start and this would be our end, and end is already pointing to our ith index, right? This for loop, the I present in this for loop, right? अब हमें क्या करना होगा, हमें पता है कि for this particular window sum is greater than 69. So what if we start removing the elements from this window? Now the question would be, where should I start removing the elements? देखो हम left, we were coming from left to right? मतलब हम लोग लेफ्ट से सारे एलिमेंट्स लेते थे, आगे जा रहे थे, राइट? तो यहाँ से राइट हैंड साइड से रिमूव करने का कोई सेंस ही नहीं बनता है, इसको हमने ऑलरेडी इंक्लूड कर रखा है. तो पीछे से स्टार्ट जो है हम उसको हटाते हैं, जो हमने प्रीवियसली कभी कवर कर रखा था अपने पास्ट में, दैट एलिमेंट वी वांट टू रिमूव. सो इफ यू डू 76 minus 12, which will give you 6 minus 2 4, and 7 minus 1 will give you 6. So your current sum is equals to 64, and at the same time we'll move our start pointer ahead, right? Now अब यहाँ पे आप देखोगे कि ये जो sum है, now the sum is lesser than your target. It is lesser than your target, right? Now once the sum is lesser than your target, what you want to do, you want to increase your sum, right? Now we did this particular window technique in hope that this particular subarray may form, or maybe the elements for this particular subarray may be equal to your given sum, right? We will try in one more case to tackle that example, but ठीक है. As of now, so you want to, my sum has now is been decreased by the target, मतलब हमारा टायर से छोटा है, हम सम को बढ़ाना चाहते हैं, so we'll move in the another right hand direction. So I will come here and my current sum is 64. 64 plus 5, which will give you 69, right? So you will just return here start plus 1 and you will return I plus 1. That would be it, right? But हम एक ऐसा केस देखते हैं जहाँ पे once when we shifted a start pointer, तो ये particular window हमारा आंसर हो गया होगा, right? So in that case we can take the first example itself. So 1 2 3 7 5 and the target is 12, right? So dry run समझना जरूरी है. 1 2 3 7 5 and the target is equals to 12, right? So sum is 1 1 plus 2 3 3 plus 3 9 9 plus 7 कितना होता है, मैं सही जा रहा हूँ ना? हाँ 6 9 plus 7 it's 16, right? Now your sum has been uh, सही किया गया मैंने क्या? नहीं यार, सही नहीं किया मैंने. 3 plus 3 6 होता है, ठीक है. 7 plus 6 हो गया 13. Let me rub it and write it again. 7 plus 6 हो गया 13, ठीक है. Now this is be my start pointer. I've got a window where the sum has been decreased, has been increased by my target. तो क्या मैं विंडो को अब छोटा करूंगा, जैसे स्लाइडिंग विंडो होता है कि we have a two pointer, right? This start and this is end, which is pointing to end equals to y, you can say. I'll move this element from the first, or let's say the leftmost side, and now my current sum would be 13 minus 1, जिसको remove किया है, जिसको start plus plus किया है, उसको हटाना तो पड़ेगा. So 13 minus 12 will give you 1, right? 13 minus 1 will give you 12, right? And you can clearly see this 12 is greater than is equals to a target. So that means this is my first sub array, right? This index, like this is the summation here, this is the prefix sum you can see, but we can clearly track the index. We can just say return start plus 1, and you can say return end plus 1, right? And that would be it, right? Please pause the video here, try to code this approach by yourself. But before moving ahead with the approach, let me give you the steps. So first step would be that you write your for loop. Second step would be inside your for loop, you will have a condition like if sum equals to s, then you will return what? You will return, uh, what you will return? I plus 1 as your end pointer, and you will return st plus 1. Yep, because st would be pointing to 0. Now there would be another case where your sum has exceeded, So in that case, you need a sliding window techniques. Now the reason I have written while loop here, why I have written while loop here, actually I couldn't understand why you written while loop here. We want to remove elements, so why can't we use the for loop? Because while loop is something, when we use the while loop because we don't know how many times we need to remove the elements, right? So that is why we use a while loop where we can specify our condition. If my current sum is greater than my target, and then the windows should have an element left, right? That means our start pointer should be less than our end pointer, and end is nothing but your current I, right? If that is the case, then remove the elements. And how you will remove the elements? You will do sum minus equals to array of st, and you need to remove it and do an st plus plus as well, right? That is the case, yeah. And again, you will have a check here that if sum is equals to s, then return the particular indexes. I have given you enough hint, enough pseudocode, so please pause this video, try to code this approach yourself. We will not do the live coding for this optimized technique because we have already discussed everything here itself. So please pause this video here. I will do the same and let us see the code. Okay, let's assume. So we have this thing. Now we have a first case that if my sum is equals to s, we need to return I plus 1. Not, we need to return st plus 1 and what else? So if sum is equals to s, we need to return that is al dot add st plus 1 and al dot add I plus 1, right? And in this case, you will just return my array list. Now, if that is not the case, that is my sum has been greater than my target, right? So in that case, as we decided, we'll use a while loop to remove, or let's say basically to do a sliding window technique here. What has happened? Yeah, if my sum is greater than s, and there should be elements left to extract from my window, right? That is if st is less than I, that is my start pointer should be lesser than my end pointer. If that is the case, we're gonna deflect it from our array, that is st plus plus, right? And we'll have one more extra check that if sum is equals to s, then or even better, let me just copy this thing here. Sum is equals to s, then do this part. Let me ident it. Yep. Uh, yep, makes sense. Looks good. Let me indent this more. ठीक है. Makes sense. And if that is not the case, at the end of the for loop, if at any point of time we have not returned our array list, then it will add a 1 and it will return. That is it for this video. And if you're still with us, you have watched the entire video, then do connect with our community and uh, we have launched one DSA 360 sheet as well. I always say in my all of the videos that there's a bunch of prerequisite question you must have in the mind, right? जैसे ये question था, आपको sliding window पता नहीं होता तो आप कैसे लगाते इसको? So this was a variation of a standard question that was a sliding window technique. And similarly, there are two pointers technique and several algorithms you must have it in your mind, right? So you can go through that 360 sheet. Um, I attach that sheet in my every of one of the video which is coming now, and you can learn more about the data structure that is starting from arrays, greedy, binary search, recursion, strings, DP, heaps, try, segment trees, disjoint set, everything we have made on our channel, and definitely in the coming time we'll be coming up with the new videos of development as well. So that is it for this video. Till then, keep learning, keep going. Bye and take care, guys. Yep. So that was all, and we have the successful submission as well. Till then, bye bye.